How is turbulence simulated in a wind tunnel? Have you ever wondered how NASCAR teams test their cars for performance on the track? One key aspect is simulating turbulence in wind tunnels. Turbulence is that chaotic airflow that affects how a car moves through the air. It plays a big role in a car's downforce and drag, which are critical for speed and handling. So, how do engineers create this turbulence in a controlled environment? First, they use turbulence generators. These are devices like grids or screens placed in the wind tunnel. They create disturbances in the airflow, mimicking the conditions a NASCAR car faces during a race. By adjusting these generators, engineers can change the intensity and scale of the turbulence to match real racing scenarios. Next, there's flow conditioning. Wind tunnels often have flow straighteners and honeycomb structures that help shape the airflow before it hits the car model. To simulate turbulence, engineers can modify these components or add elements that induce turbulence. This ensures that the airflow has the right characteristics when it reaches the test model. In addition to these physical methods, NASCAR teams are increasingly using computational fluid dynamics simulations. These advanced computer models help simulate how turbulent air flows around the car. They incorporate turbulence models that show how turbulent eddies and flow separations develop. Sometimes, machine learning techniques are used to refine these models based on actual wind tunnel measurements. This combination helps improve the accuracy of aerodynamic predictions. Another important step is localized calibration. The turbulence models used in computational fluid dynamics are calibrated with wind tunnel data. This means engineers adjust the turbulence parameters to align the simulations with what they observe in the wind tunnel. This calibration is vital to ensure that the effects of turbulence on the car's aerodynamic loads are accurately captured. In practical terms, simulating turbulence in a wind tunnel is essential for NASCAR teams. Turbulence affects how air flows over the car, influencing downforce and drag. Engineers use this simulation to test different aerodynamic packages and make adjustments to body shapes, spoilers, and splitters. This helps optimize performance for various track conditions. By combining physical turbulence simulation with advanced computational models, NASCAR teams gain a better understanding of how turbulent airflow impacts their cars. This integrated approach allows them to fine-tune aerodynamics, giving them a competitive edge while following NASCAR regulations that limit wind tunnel testing time. So, the next time you see a NASCAR car racing by, remember the intricate process of simulating turbulence that helps teams achieve peak performance on the track.